Alright, so we're doing cosine rule. So once again, it's good to look at the triangle, especially when you're using complicated formulas. You need to know what side's meaning what. So remember that your lowercase letters are always used to symbolize a side length. Okay, and your uppercase letters always symbolize a vertex or a corner. So, we're not going to go into deriving this formula. Alright, you were shown it last year as well, so this should be revision. There's two versions of the cosine rule. Okay, the first version you're looking at right now. Okay, and you can see here how a squared is equal to b squared plus c squared. So what does that part of the formula remind you of? That's Pythagoras. Alright, but then because this is a rule used for non-right angled triangles, you had to include this other section here, which takes into account the angle at A for finding side A. Okay, and that's a really important point. So the A, the lowercase a and the capital A have to match up. So for example, if you're using this formula, you're finding a missing side length. A has to be your missing side, and the corresponding angle A has to be opposite, like that. Alright? That's the main area people stuff up when using this rule. B and C are interchangeable, as in it doesn't matter which one you assign as B or C. It won't make a difference to your workings out. But A is very important. If we want to find out a missing angle A as well, we can use a different version of this formula, a rearrangement of it, as shown here. So you can see here how cos A is now the subject of the formula. So whatever you work out from b squared plus c squared minus a squared over 2bc, there's going to be one final step that you actually have to do to find out the missing side, the missing angle A. And what's that final step going to be? So at the moment this formula works out cos A. So how would you find out just A? Inverse cos. Perfect. So actually, you could write this down as another version of the formula for yourself. A is going to be equal to the inverse cos function of everything on the right. So you might want to write this down as well and have it handy to remind you to do that final step. Similarly, if we look at the equation above, I'm just going to erase some of this mess here. There's going to be a final step to the equation for the side length too, isn't there? What's the final step going to be to find out A, the side length? The square root. So actually you have to do a square root of everything on the right. So b squared plus c squared minus 2bc times cos A, brackets. If you forget that step, that's probably one of the most common mistakes people make when using these formulas. They do everything else right. They pick the right A values, but then they forget that there is a final step. You have to do inverse cos or you have to do square root, respectively. Now, similar to other trig workings out, if you've got a missing side, you can actually just use algebra solve. But if you've got a missing angle, algebra solve is a little bit more complicated, so it's better that you just write down this formula and use it. Right, so the next thing you're going to have to remember is when to use cos rule. And hopefully you remember from last year a little bit, but there's two scenarios when you're going to use it. Scenario 1 is to find the unknown length, and that's when you have two side lengths and an angle between them. So if we're going to visualize scenario 1, let's just go up to our triangle up here. Okay, you need to have this side here, and the angle between them here, and you can find the missing side A. Okay, that's when you would use in scenario 1, okay, to find A. You have to have the two sides with the angle in the middle, and it will find the opposite side, the one that's missing. Scenario 2 is a bit easier to explain. It's finding an unknown angle when you have all of the other side lengths. So you have A, B, and C given to you, but no angles. Okay, so you can find any angle using the cosine rule. So if you're given a triangle that's non-right angle, and it has no angles in it, but it has all the side lengths given, you can find out any of those angles. Remembering to assign A correctly, of course. Right, so let's put it into practice. Finding a missing side length. So I'm going to just leave this with you for a minute, see if you can work out the missing side B to 2 decimal place. Off you go. Right, so how do you always start off a trig question? Once you've identified the formula, what should you do? Label it, yep, okay, so if we just write down our formula first of all, we're going to be using the a squared version. So equals b squared plus c squared. It's the same as Pythagoras. And then how does it finish? Minus 2 bc times cos of A. Nice, right. Now let's label our actual sides here. If we're finding out this one, then even though they've called it B, we should actually call that side A. Alright? Because this corresponds to angle A over here. And the other two don't matter, so you don't really need to label them as much. So we're going to have, if we substitute our values in, we're going to have now B squared, the unknown, it's a bit confusing really, equals, and then one of the sides squared, plus the other side squared, minus 2 times 16 times 24 times cos of the angle 53. And if you just type that in your calculator with a square root over the top, you can find B straight away. So just write it out in full. Okay, and so the answer B comes out as 19.23 if we're doing 2 decimal place, yeah? Cool. Alright. Well done. And there's no units for that because it doesn't say meters or anything, so you can just leave it like that. Alright, finding a missing angle. So, off you go. Have a little go at this if you haven't already. Alright, so this one, we're going to use our cos A equals version. So what does cos A equal? Over 2bc. So it's just a rearrangement of before. So to find A, what do we have to do? To find out A on its own, inverse cos of everything over here. So you're going to have your b squared plus c squared minus a squared over 2bc. And that's what you're going to sub into and then solve with. So if we label our sides now and work out what A is, so A is going to be your angle over here, and the A opposite is going to be lowercase a, and the other two are interchangeable, so we can just call this B and this C. So if you type all this in your calculator, you'll be able to find out what the angle comes out as. So 26.2 plus 16.7 minus 18.9 all squared all over 2bc. Okay, and the answer comes out as the answer is 46.0 degrees. Alright, nice. Alright, so first thing with this question is you've been told to use cosine rule. However, you don't always know that in the exam. They don't always explicitly tell you use cosine rule. So first of all, to find BD, which is from along this diagonal line here, how would you know to use cosine rule? What's the giveaway? Yep.
2 side lengths.
Yep. Okay, so you got 2 side lengths, correct? And an angle between. Hence its cosine. Sine rule is always when there's opposite pairs, angles and sides. But this one is where you just have simply 2 sides and an angle. So it's cosine rule. So remembering that the missing side we will call lowercase a. Well, they've called it x, but in the formula it's referred to as lowercase a. And then the corresponding angle is capital A. So you're writing out your formula. A squared equals b squared plus c squared. And then remembering the minus 2bc cos A addition. And subbing in the values, we're going to now have x squared, because x is the unknown side A, and then the other two don't matter. So 7 squared plus 19 squared minus 2 times 7 times 19 times cos A. And then, before we type this in our calculator, what's the final thing you have to do with this? Square root. So don't forget that to find out x on its own, not x squared, you need to square root everything. So before you start typing it in, just work it out on the page first, and then you type in the final thing into your calculator. Okay, and if you type that into your calculator, you should get to 2 decimal places 23.88. Did everyone get that? And that'll be in meters now. So, what we'll now do is erase those lines, and we'll start again with a fresh triangle, and we're going to put the new side length in of 23.88 on this side. And now you can see that you have another pair of sides and a corresponding angle in the middle of them. And the next question is going to ask you finding the length of C to D, which is this bottom side here. Okay, so you're going to be finding there, alright? So that's now lowercase a, and this is effectively your uppercase A. So it's very similar procedure to before, so you're going to use this formula here. A squared equals b plus c squared, etc. Subbing in your values. So this time we're going to have k squared is equal to 23.88 squared plus 14 squared minus 2 times 23.88 times 14 times cos of the angle A, 82. And then just remembering to square root the answer that you get for that. And so you should get to 2 decimal places 23.88. Is that right? No, hang on, wrong bit. 64.41. Is that right? 25.94. That looks right according to the diagram. Okay. Just being lazy here, not doing it myself. So that's in meters as well. Now, last bit